Welcome to Core Aptitude Training Institution video lecture series. In this video, we are going to discuss about remainder theorem. Find the remainder of 9 into 77 into 43 into 14 square divided by 21. This expression is a fraction. First, try to reduce the fraction. I can reduce this as 3 times and this is 7, and again 7 is 1 times and this will be 11. The denominator has been completely reduced to 1. Any numerator divided by 1, you will get the remainder as 0. Now let's go to the next problem. Find the remainder of 9 into 76 into 43 into 14 square divided by 45. First, try to reduce the fraction. So I can write 3 square into 5. This is 9 into 76 into 43 into 14 square. Now this will get cancelled out and the problem got reduced to 76 into 43 into 14 square divided by 5. Now I cannot reduce this fraction further. For this, one can always find out the multiplication of all these given values divided by 5, you will get the remainder. That is one way of solving this problem. It will take a lot of time. Now the next approach could be, I know that the denominator is 5. I am trying to rewrite the numerator values to anything less than or equal to 4 and anything greater than or equal to minus 4. So in the range of minus 4 to plus 4. What is the multiples of 5 closest to 76, 75 and 80? 76 and 75, the surplus value is plus 1 and here the deficit value is 4. Divided by 5, I am going to write either in the surplus value or in the deficit value, right? Closest to the multiples of 5. Now 76 surplus value is plus 1. You can even write minus 4, right? But let me write here. I will write all the small numbers without considering the sign on the left hand side. Small numbers without considering sign. All the large numbers, right? And what about 43 divided by 5? 43 divided by 5, I can say it as plus 3 or minus 2. So I can write minus 2 here, plus 3 here. Because I am going to write the large numbers here. And 14 divided by 5, I can write plus 4 or minus 1. Because 10 is closer to 14, 15 is closer to 14. 10 to 14 there is a surplus, the remainder is plus 4, and 15 there is a shortage. Shortage is nothing but the deficit, I can say minus 1. So here I can write minus 1 the whole square, here into plus 4 the whole square. Now look at this. Which will be better for me to calculate? It will be very difficult for me to do the multiplication of the larger numbers. So I am just trying to avoid this and let me go with the small numbers. Plus 1 into minus 2 into minus 1 the whole square. So it will be minus 2 divided by 5. I cannot express the remainder as a negative term. You know that these are all the deficits, right? What about these positive values? 0 to 4 are all remainder, that is surplus. Now minus 2 divided by 5, it's a deficit. How can I write it as a remainder or surplus? I can say it is 3 by 5. We initially cancel the common factor, that is 9 on both numerator and denominator. So multiply the last value by 9. Because denominator in the question is 45. So I can write 45 here and 27. So here answer is 27. Find the remainder of 77 into 76 into 43 into 14 divided by 15. Now is there any possibility to reduce this fraction? Even if I write the denominator as prime factorization 3 into 5, the fraction is already in the reduced form. But numerator values can be changed in the range of minus 14 to plus 14. I can rewrite the numerators anything from minus 14 to plus 14. Now how to rewrite this? 75 is divisible by 15, plus is plus 2, or the deficit is minus 13. But which value you can write to make the process easier for us? Plus 2 will be better, right? Into. This will be 75 is divisible, so I can write plus 1. And 43 divided by 15. You know that 45 is divisible by 15. If I write the surplus here will be 13 plus 13. But if I write the deficit is the next multiple is 45. So minus 2 will be better. Into 14, you know that surplus is 14 because for 14, 0 is divisible, 15 is divisible by 15. I can say the surplus is 14. So deficit is 1. Deficit is always denoted by the symbol minus. So minus 1 divided by 15. 4 divided by 15. Find the remainder of 2 power 48 divided by 8. So this is a fraction. Yes, I can reduce this fraction. So this is 2 power 48 divided by 2 power 3. This has become 2 power 45 divided by 1. So here remainder will be 0 because the numerator and the denominator have a common factor 8 that got cancelled out, and you are left out with the denominator as 1. So in that case the remainder will be 0. Find the remainder of 69 to the power 312 divided by 12. Can you rewrite this fraction in the reduced form? So first let me write this denominator as 2 square into 3, 69 into 69 to the power 311. Now I can cancel this and this will be 23. So I can write this as 23 into 69 to the power 311 divided by 2 square is 4. I cannot reduce this further, so let me keep like this. What is 23 divided by 4? There is always scope for you to convert the numerator values in the range of minus 3 to plus 3. What is 23 divided by 4? Either I can write it as plus 3 or minus 1. So plus 3 is the surplus, and what is the deficit? Deficit is 1. So I can write it as minus 1 because the next multiple will be 24, right? So deficit is 1. To reach this number, to reach the next multiple, the deficit is 1. The shortage value is 1 into 69 divided by 4. The surplus value 68 is divisible. So you have extra value 1. So 1 to the whole power 311 divided by 4. You will get minus 1 divided by 4. You know that you cannot express the value in minus because minus indicates the deficit. You need to always tell the remainder in positive, right? So you can convert this into 3 by 4. Now you have already cancelled out 3. So you can multiply the last answer with 3. So 9 by 12 because the divisor should be same as of question. Remainder is 9. Find the remainder of 69 to the power 312 divided by 36. Now is there any possibility to reduce the fraction? Reduce it. Write the denominator in the prime factorization. I can write this as 3 square, that is 3 into 3 into 4. What about numerator? 69. So I can take out two 69s outside because there are 3 into 3 in the denominator. So 69 into 69 into 69 to the power 310. Now this will be 1 times, this is 23. This also will get cancelled, 23. Now I cannot reduce this 4 because all the numerator values are odd numbers, right? So I can take this as 23 into 23 into 69 to the power 310 divided by 4. Now, numerator values can be rewritten in the range of minus 3 to plus 3. Now 23 divided by 4, what is the value? It is minus 1 into minus 1 into plus 1 to the whole power 310 divided by 4. Now this is 1. So 1 to the power 310 is anyway going to be 1. So you got 1 by 4. 4 is the divisor, whereas in the question it is 36 because I have cancelled out 9. So multiply the final fraction that you got with 9. So it will be 9 by 36. So answer is 9. Find the remainder of 3 to the power 91 divided by 26. Now this is already in the reduced form. So I cannot reduce it further. Now denominator is 26. Now the numerator is 3. Numerator values are 3. So I can say it is already written in the range of minus 25 to plus 25. Now the challenge is, can I rewrite the numerator closer to the denominator, maybe 25 or 27. Why 25 or 27? Because if I write this as 27 by 26, I can write it as plus 1. If I write it as 25 by 26, I can write it as minus 1. Right? So, is there any power of 3 closer to 27 or 25? I can write this as 3 power 3 is 27 to the whole power 30 into 3 power 1 divided by 26. So I can convert this as 27 to the power 30 into 3 power 1 divided by 26. So the challenge is, I converted this numerator close to the denominator it is 26. Because if I write anywhere close to 25 or 27, I can convert this value as plus 1 or minus 1, right? So 27 divided by 26, I can write it as plus 1 to the whole power 30 into 3 power 1 divided by 26. So this will be 3 divided by 26. So answer is 3. So the next case that we are trying to do is, I am not able to reduce it. We have written minus 25 to plus 25. And third thing that we can do is converting numerator close to denominator. So how much close? It should be either plus 1 or minus 1. Denominator is 26. I have converted this value of numerator in such a way I get closer to 26. Closer to 26, 27 is possible, 3 power 3. So I have rewritten the entire expression as 3 power 3 to the whole power 30 into 3 power 1 and I got the result. Find the remainder of 2 power 14 divided by 7. Can you pause for a few seconds and try to find the answer? What will be the answer for this? I know that I cannot reduce this further, so reduction is not possible. It's already written from minus 6 to plus 6. It is not possible to convert the numerator values. And third, can I write the numerator closest to the denominator? So 2 power 1 is 2, 2 square is 4, 2 power 3 is 8. Yes, I can write this as 2 power 3 because 8 and 7 are closer, right? 2 power 3 to the whole power 4 into 2 square divided by 7. So this is 8 to the power 4 into 4 divided by 7. 8 by 4 is 1 into 4 divided by 7. So I can write it as 4 by 7. So answer is 4. So we have done writing numerator close to denominator by how much? Either plus 1 or minus 1. Now let's go to the next sum. Find the remainder of 3 to the power 380 plus 3 to the power 386 divided by 25. This you can approach in two ways. First, you can find the remainder of 3 to the power 380 divided by 25. And you can find the remainder of 3 power 386 divided by 25. And you can add both the remainders to get the result. Let's take 3 to the power 380 divided by 25. Firstly, reduction is not possible because both the numerator and denominator, the fraction is already in the reduced form. I cannot reduce it further. Secondly, numerator value is already 3. It is also not going to help me out, right? In the third case, can you rearrange the numerator close to denominator either as 26 or 24 so that I can rewrite the values in the numerator as either plus 1 or minus 1. Because 26 divided by 25 will give you plus 1, 24 divided by 25 will give you minus 1. But in this case, here 3 power 3 is 27, so this is also not possible. Now I am going to introduce one more option because first, second and third is not possible. So fourth option is reducing the power, reduction of power. Before going for this method, let me introduce a small concept, 3 power 380 divided by 25. Now what is 3 power 1? Is 3 divided by 25. What will be the remainder? 3. 3 square, 3 into 3 will be 9. 9 divided by 25. So remainder is 9. 3 power 3. 9 into 3 is 27 divided by 25. Remainder will be 2. 3 power 4. 2 into 3 is 6. 6 divided by 25. Remainder will be 6. 3 power 5. 6 into 3 is 18 divided by 25. Remainder will be 18 and so on. Like this you continue to do it. You will get 3 power 10 is 24 divided by 25. I can say remainder is 24. Here I can write either in positive or in minus. Positive means writing the remainder. Negative means writing the deficit, right? So here I can say this as minus 7. This is minus 1. So what will be the next value? 3 power 11 will be equivalent to minus 3 or I can say plus 22. 3 power 12 as minus 9 or plus 16. This is plus 3 and this is minus 3. So 3 power 20 will be equivalent to minus 24 or plus 1. The moment I write 3 power 21, 3 power 21 will be equivalent to remainder of 3. It means after this 1, whenever you get the remainder as 1 and this will again repeat. It means 3 power 21 will be same as 3 power 1. This entire thing repeats for every cycle of 20. Cycle of 20, right? I need to find for 3 power 380 divided by 25. I need to find the remainder. I'm just trying to reduce the power, right? So 3 to the power, I need to find the remainder of 380 divided by 20 divided by 25. Why 20? Because I know that this repeats for every cycle of 20. So what is 380 divided by 20 remainder? It will be 3 power 0 divided by 25. What does it mean? 3 power 0 means it's nothing but 3 to the power 20 divided by 25, because 20 divided by 20 I will get the remainder as. So whenever you get remainder as 0, right, that will be equivalent to 3 to the power 20, because it repeats for every 20 cycles, right? So here fortunately 3 power 20 is plus 1, right? Whenever you are getting plus 1, you will get the next value repeating, right? So I can say either I can check for 3 power 20 divided by 25, or simply 3 power 0 is anyway going to give you 1. So it will be 1 divided by 25. That is your answer. Now instead of doing all these cycles calculation, can you directly arrive at this number of 20? Is it possible to do that? Let's see. 3 to the power 380 divided by 25. Now how to find directly that this will repeat for every cycle of 20? Now very simple. We'll just find out number of numbers less than 25 co-prime to 25. Now how many number of numbers less than 25 co-prime to 25? Now what are the numbers less than 25? 1, 2, 3, 4 up to 24. Now out of this, how many numbers are co-prime to 25? What is co-prime? It means HCF of the pair of numbers should be 1. So 1 and 25 co-prime because HCF is 1. 2 and 25 is co-prime. 3 and 25 is co-prime. 4, and I will have all the numbers, right, except 5, 10, 15, 20. It means I'll get 20 numbers less than 25 co-prime to number 25. So this is one way of finding the number of co-prime 20, and you got the cycle of 20. Again, this method is not going to be efficient because I cannot manually count the number of co-primes for a number, right? So I need to go for some better method. Now what is a better method? Now can you write this 25 as the prime factorization? 25, the prime factorization will be 5 square. Right? A number written in the form a power x, b power y, c power z and so on, number of co-primes of a number less than n will be equivalent to number into 1 minus 1 by a, 1 minus 1 by b, 1 minus 1 by c and so on, right? Okay, so for 25, number of co-primes will be 25 into 1 minus 1 by 5. I will not consider the square, I will consider only the prime numbers in the base. So it means 25 into 4 by 5, you will get 20. Can you find the number of co-primes for 15? So number of co-primes of a number less than 15 will be equivalent to 5 into 3 is a prime factorization. So I can write 15 into 4 by 5 into 2 by 3. So this will get cancelled. So the number of co-primes for the number 15 will be equivalent to 8. Can you do it for 100? So the number of co-primes will be equivalent to, I can write the 100 as 5 square into 2 square. So this will be 100 into 4 by 5, 2. So this will be 40, right? If the divisor is 100 and you have numerator as x power y, if you cannot reduce this fraction further, I can change this value as x power remainder of y by 40 divided by 100, right? Because I know that this, since the denominator is 100, this will be repeating for every 40 cycles. So I'm just trying to reduce the power. Reducing the power, I just replace the power with remainder of y by 40. Now let's come back to this. It's 3 power 380 divided by 25. You know that reduction of power is possible. Reduction of power, 25 is the denominator. 25 number of co-primes will be 20. So I can change this power to 3 to the power remainder of 380 divided by 20 divided by 25. So I can say it is 3 to the power 0 divided by 25. It is also equivalent to 3 to the power 20 divided by 25. Because it repeats for every 20 cycles, the 3 power 20 should be always 1, right? For that, instead of writing it as 3 power 20, I can simply write it as 3 power 0 divided by 25. It's going to anyway give me 1. So I can say 3 to the power 380 divided by 25 is 1 by 25. Now let's go to the second part of it. 3 to the power 386 divided by 25. So I can change this power, reduce the power, 3 power 6 divided by 25, because the number of co-prime is 20, reduce it, 386 divided by 20, remainder replace it, 3 power 6. I can write 3 power 3 to the whole power 2 divided by 25. So 3 power 3 is 27 square divided by 25, 2 square divided by 25. This will be equal to 4 divided by 25. First part is 1 by 25. Second part is 4 by 25. So your answer will be 5 by 25. Right? Now find the remainder of 6 to the power 8963 divided by 23. In this case, reduction of fraction is not possible and the numerator values are anyway less than 23, and I cannot write it even closer to 23 because 6 square is 36. 36 divided by 23, the difference is not plus 1 or minus 1. So I cannot go with the third one also. So only method that I can adopt here is reducing the power. So number of co-prime will be equal to 22, because 23 can be written as 23 to the power 1. So I can write 23 into 1 minus 1 by 23. So 22 by 23. So 23 and 23 will get cancelled. So number of co-primes for 23 will be 22. For any prime number of co-prime will be the prime number minus 1. So for example, here 23 is a prime number. The number of co-prime will be 22. For 17, number of co-prime will be 16. 6 to the power 8963 divided by 22. Just replace the remainder. Here the number of co-prime is 22. So it means this will repeat for every cycle of 22. Correct? But in some cases, it might repeat even for cycle of 2, even cycle of 11. Why 2 and 11? Because 2 and 11 are factors of 22. Right? So in this case, I can say it may be 2 or 11 or 22. But why we are considering 22 here? Because 22 is the best of all the cases. Even if it repeats for 2 cycles, it will be repeating for 22 cycles. Even for 11 cycles, it will be repeating for 22. Since 2 and 11 is giving a lot of ambiguity to solve the problem, I am trying to approach the problem considering the number 22. Right? Because I really don't know whether it will be repeating for every 2 cycles or 11 cycles, but I definitely know this will be repeating for every 22 cycles. This will be 6 to the power 9 divided by 23. So I have done the reduction of the power. Now can you approach the problem? What is 6 power 9? I can write it as 6 square to the whole power 4 into 6 divided by 36 to the power 4 into 6 divided by 23. I can write this either as 13 to the power 4 or minus 10 to the power 4. Let me write it as minus 10 to the power 4 into 6 divided by 23. So this will be 100 square. So 100 square into 6 divided by 23. It will be 8 square into 6 divided by 23. So I can write 64 into 6 divided by 23. 64 divided by 23. I know that 69 is divisible. So I can say it's minus 5 into 6 divided by 23. So answer is minus 30 divided by 23. It is again minus 7 by 23. I can write 16 divided by 23. So 16 is my